So again, the first thing we want to do is ask ourselves, is this a standard integral? No. Can I algebraically rearrange it to something I can do? No. Can I apply substitution here? Well, there's no inside function, so no. So then I have to think, well, maybe I can apply integration by parts. I don't want to go to integration by parts right away. I need to make sure that I do the easier methods first. And then I'm going to say, well, maybe I can apply integration by parts. So again, integration by parts involves a few things. I need to break it into parts. Okay, I need a u part and a dv part in my original integral. And I need to select my dv part such that it's the most complicated part of this expression that I know how to do. Okay, so once I've done that, I need to generate the rest of the parts and I can apply the formula. And then once I've applied the formula, I can check the new integral, and that's the whole purpose of this. Is all it's doing is rearranging the old integral into a new integral that's slightly different and hopefully easier to do. So I'm going to start with my main criteria here. I need to select a dv part that is the hardest integral that I can do. If I select that as my dv, I can't integrate that. Okay, that's a problem. Okay, so I'm going to select the x dx as my dv because I know how to integrate that part. Okay, so my dv is my x dx, which makes the u part of this is equal to log x. Okay, and I can pretty much differentiate most things, so that shouldn't be a problem. So to generate the rest of the parts now, I need to integrate to get my v. So my v is equal to x squared over 2. I'll write that out a little bit nicer. V is equal to x squared over 2. I integrate to get that. To get my du, I need to differentiate. So du is equal to 1 over x, and then I'm going to move the dx over to that side. Okay, so there it is. I've got all the parts that I need for this expression. Okay, so that's clear. That's a dv here. So going to my formula, my new integral should be u times v. So it's going to be log x times v, x squared over 2. Okay, so there's my u times v part of the formula, minus, just going to move this down a little bit so that I have a little bit more room to work, minus the new integral is going to be v du. Okay, so I'm going to combine those together to v du. Okay, so what color should I? Well, I'll just write it out separately for now. So I'm going to have my v times my du. It's going to be dx over x. Okay, I can simplify that expression, and this new integral is definitely easier than the one I started with. Okay, so x's cancel out. I'm going to take that 1/2 out, and it's just going to be x dx. So there it is. I definitely can integrate this, so I can resolve that integral. It's going to be x squared over 2 log x minus x squared over 2 divided by 2, so x squared over 4, and don't forget the plus c because it's an indefinite integral. So there it is. The integral of x log x is going to be this expression here. So again, I need to go through my simpler methods. If I can't do it by substitution, I can try integration by parts. So same thing here. I can't use a rearrangement. It's not a standard integral. Substitution, no, there's an inside function, but substitution doesn't work. I have to try integration by parts. Okay, so the integration by parts, when I choose my parts for u and dv, my dv part must be the hardest part of this integral that I can do. Okay, so there's my dv part. I can integrate that. Okay, whereas if I choose x log x dx, I cannot integrate that. Okay, so there's my dv. That means that this must be my u. Okay, I need to generate my parts, du by differentiating. Okay, my v is by integrating. So I have dv, so I integrate to get v, which is x cubed over 3. Now that I have my parts, apply the formula. Okay, the formula is u times v. There's my u. This is my v for the function, x cubed over 3. There's the v part of my formula. The new integral, this is a key part, the new integral I'm going to generate, this is the whole key to this, is I want to have an integral that can be done. So this new integral is going to be v du. So v is right here. So v is x cubed over 3, and then times du is going to be this 1 over x dx. So that's where all the parts come from. When I simplify it, is that new integral one that can be done? Okay, so this is going to be 1/3 integral, x's cancel. Yeah, this is just power rule integration. The new integral can be done. It's easier than what I started with. So that was the whole point of doing integration by parts. I have an equivalent integral expression to what I started with, but the new integral can be integrated. So I end up with x cubed over 3 plus c. So this simplifies to x cubed over 3 log x minus x cubed over 9 plus c. So there it is. There is my antiderivative function.